Hello friends, welcome to VLSI Techno. In this video, I share the basic flow procedure of Xilinx tool Vivado. So I start the Vivado tools. When I start the Vivado tools, this window will appear. So I am starting. So I start any project. So firstly we click create new project. If you are already done uh, previously any Vivado project, then click in open project and select your project to start the Vivado tools for further modification or further procedure. So start with creation of new project. So double click on it, it will appear a window new project, and go to next and provide the location of your project and project name. So I am provide the location. Okay, you can browse it. There it is also option to browse the your location. So I make the location it here, and the name you can name any. So I make the name demo and move to forward, and you select here to create project sub directory, so that all folder are present in one directory. So here is another a step in which they are showing different option to choose. First one is I am working on RTL, so we select here RTL. If you are already done some analysis and synthesis, then you can use this one. Otherwise, if you are interested in IO planning project, then we click here. So basically I am starting RTL project, so click here. If we have a any already make some very low code or files, then select a keep this one. If you are not, then click here do not specify source at this time. So move next. Here is the in next step, it show default parts. So if you are selecting this, it show board. So it depends on your FPGA board, and this is showing FPGA board, different FPGA board. So if here is the option to select the your board. So if you want to choose any board, so I am choosing Nexus for DDR. So what is Nexus for DDR? It is a FPGA board, so it is a part of Digilent. So go to for knowing to know more about this FPGA board, go to Digilent site and may look at this Digilent site. Many FPGA board are available. So I am choosing Nexus for DDR. So click on it, it will open, and go to resource center. Actually this is the giving the price and their features. Actually I want to know um, pin status, what is the pin, what is the its features. So go to and go to reference menu. So this is the reference manual of a Nexus for DDR. So this is Nexus for DDR. This is the specification of pin. This is a buttons, slide switch, LEDs, seventh segment display, seventh segment LEDs, and this is the tricolor LEDs. So this is the specification. You can also download here a master constraint file. Actually these are a master constraint file. This one XDC, this user constraint file. This is for a IES IESE, and this is for Vivado XDC Xilinx design constraint. So you can download it. When downloaded it, um, it will look like this. Click on it. Okay, this is the master XDC file. So in this file all pin and their supply voltage and their location are given. So move to next, selecting the board. Actually I am selecting board here, this one, Nexus 4 DDR. Okay, project is open. Okay, after this window will come. In this window, this is a project manager, IP integrator, simulation, RTL analysis, synthesis, implementation, program and debug. So firstly I start with adding source file. So click on it here, this one add here, both are same. So click on it and go to create, select add or create design source. If you have already Verilog file, then click on add files. Okay, you have no, then create files. So if you have no any Verilog files, then create file is necessary. So give the name. Here is the option, we are choosing Verilog file, VHDL file, system Verilog files. So there are option to which type file type you are using. So I am using here Verilog file. You can also choose VHDL file if you have a VHDL coding. So here I am make the name demo or any counter and click on it. Here is the option to create give the file location. So you can give any location, but make it default local to project. Otherwise when opening your project and run the file, it will show sometime error if your location of project is not proper. So it is better to keep the by default local to project. Click on OK and move OK. So if you are adding two or three files, just click on it and add. If you want to add more source files. Okay, I am here only add one file. Move to finish. Okay, here is the option to create. So it will show how many input output you want to define. So if you want to add any files, different size, name. Okay, so now second input, if you have to, here is option which direction you want to select, input direction, output direction or in out direction. If you have a size of different, if you are using a 4 bit 2 bit, how many bit of your size, you can select here MSB or LSB as you wish. If you go to downward, just you select here, this is your choice. If you want to create 3 bit, then we select 2, 0 to 2. If you want to go 6 bit, go to select 1, 0 to 5. So it will select 6 bit. If you want to remove anything, just do this. Okay, so I have already Verilog file, so I have already created Verilog file, so it is better to okay. So I am adding direct file. I am already created a Verilog file, so this is Johnson counter file, so I am just adding it. So if you have no Verilog file, then you have to create file. So I already told how to create the file. So move to next, move to click on finish. Then after, when you click on this file, here the code is automatically show here. So this is a code of Johnson counter, and if you want to add test bench, then you can add go to add source and click on simulation, add or create simulation source. Okay, if you tick this similar uh, add or create design source, you can also write the test bench here, but main reason is that when you add this file, it automatically come here and also come here, but at the time of synthesis we have to make top model this one, not test bench. Actually test bench is working, the work is over at simulation. After the simulation there is no need of test bench, so it is better to add the test bench in simulation file, not in design source. So we are adding test bench file in create simulation source. So click here. I have already written test bench. If you have not written test bench, then click on create file, and same similar procedure you have to follow. Write the name of just like I have the name test bench counter, and click here to and follow the same similar procedure. Okay, so I have a file, so just click on here, add or here. Many, they have two options, so any option you have to choose. So I am clicking here add file, and this is my test bench. Okay, so now click on finish. So add test bench is added here. When you look at this one, this make test bench is top model. Okay, when adding here as a source, design source, as a to test adding a test bench in design source, it will appear both file, design source and as well as simulation source. So for test bench we have to add only simulation source, no design source, otherwise it will create problem at the time of synthesis and implementation. To this error will due to the test bench is already in top model, so that other if you are adding here design source, so we have to make the your source code as a top. So selecting here, when two file is coming here, so it will show like that. Here is a top model. If you select here, so here is option to create a set a top models. So okay, so we are written the code, Verilog code and their test bench. So run the simulation. Okay, this is test bench file. Okay, you can zoom it and look our folder, look at test bench. Okay, so this is test bench. Now move to RTL analysis. So in RTL analysis, just click on here and create created schematic of your code. So you can see your schematic of your code, respective to your code. So this is the schematic of my code. Okay, you can choose here, so go show your schematic. Okay, now move to synthesis. Okay, in synthesis there is another file here, also create a schematic, but there is a difference between this RTL analysis schematic and synthesis schematic. So firstly I run the synthesis, and then after I explain what is the difference between this synthesis. Okay, okay, synthesis is completed. Now move to implementation. Before going to implementation, I want to show you this one. When you click in this schematic, okay, this another schematic is come, but this schematic is differ from RTL analysis schematic. What is difference between this schematic is that Our synthesis schematic depends on board, which board you are selected. Here I selected Nexus DDR4 board. According to this board, uh, the schematic is designed by Vivado tools. If you board is select different board, if you select different board, then schematic will be different. And if you want to show the property, their report, so here we go to this one, project summary. Here synthesis with different report. So report click on report utilization, create OK. So it will show how many register or LUT are used. So this is LUTs, this is registers. So here is 8 register are used and 1 LUT are used. Here is the this amount of LUTs are available in this board. So by using this LUTs and register and flip flop, they create your schematic, and this schematic is differ from this. Actually this schematic is directly to your coding. It depends on your coding. So if you change your code, schematic will change. So this schematic is created as respect of your coding, but this schematic is not respect to only your coding, it also depends on your selected board. Okay, so in this board we are using this code, you using this one LUT lookup table, 8 registers, no mux are used, no BRAM are used, no BRAM. So it's showing the how many. This is a hierarchy in which he is showing how many LUTs, flip flop, input output buffers are used for this synthesize the code, to synthesize this code. Okay, now you can go to for planning. Okay, and go to IO port. So in IO port we define output pin and input pin according to your board. So actually I am selected here Nexus DDR4. So what pins are selected here? So this is depends on your board. So for that we have to require manual, or we have to require board. If we have board, then on board pins are already displayed. So when you go to board, this is the image of board. This one Nexus 4 DDR. So here we look out this one. Here is the name of pin. This is LEDs, this is a slide switch, this is segment display, this is a tricolor. Here is the tricolor, this one tricolor LEDs, this is push button. Okay, these are P mode, this one and this one are P mode. Here is the USB connector, this is the LAN connectors, these are FPG VGA cable connectors, and this is on off switch and power, and this is the many parts are. So if you want to know more about this, you have to read this manual, respective board manual you have to read, then you have to know the features of a board. So after that we have to put, actually if you want to show output, this LED show output, and these pins, buttons or slide switches work as input. So according to this we put here. So if output is so when go to this manual output, these are output. So starting from anywhere LED 0 to there are 16 output are available in the form of LEDs. So first I started with LED 0 and to LED 7. So give the name here H17 K15 H17 K15. Okay, in similar manner we put the all value of pins. And one important thing I want to say, here is the IO standard, so we have to select our standard, this one 3.3. so when is selected, then VCC or change, this is 3.3. okay, before it is a 1.8, by default it is this one, so by default it is, so we have to change this one. okay, so power is changed. So in similar manner we have put the package pin here. So I am pause the video and putting the pin. okay, I give the pin, package pin. So this is the pin number of LEDs. So I put the pin and now give the clock. So I want to use internal clock. Actually FPGA, this FPGA board has a internal clock. The frequency of clock is 100 megahertz. So if you want to toggle the clock of 1 hertz, then we have to write the clock divider code. So if you want to get a clock frequency of 1 hertz, 2 hertz, 3 hertz as a desired frequency, then you have to write a proper desired clock divider code. So this clock divider code will slow down the your clocking frequency of FPGA board. So I am taking here I am taking by default clock frequency. So clock frequency using port is E3, and input I am provide input through slide switch. So I am giving the J15, the pin number. Okay, here they change the supply, otherwise it will show error at the time of implementation. Okay, all input output ports is completed. Now save it. When save it, okay, so it is creating XDC file. So make the name of this XDC file. So I make the name counter. So save it. Okay, now it's saved. Now move to implementation. So implementation, routing, placing, all things are doing. So if you want to know more about this, so here is the many option. You want to know the power, how many power it absorbs. So click on here, it show the power, static and dynamic powers. So it's showing the static and dynamic power. Okay, actually this power is vary. This is power, it depends on your clocking, many things, not clocking, your coding, writing skill, and many things. For that power optimization we using many techniques, just like clock gating, pipelining, and many things. So here I am not using any power optimization technique. I am running by default, no any modification I am doing here. So after this we are going to move. If you want to know that timing summary, just click here. Okay, this one show the slack, different slack, total negative slack, number of endpoints, and many information given here, showing here. So this one the clock, timing setting. Okay, so if you want to project a status, this is the status. Okay, here utilization is showing how many utilization is showing in form of percentage. If you want to go table, it's showing in form of table. So this is a post synthesis table. Now move to implementation. Actually I have done already done synthesis. Here I am in write the XDC file, so again synthesis will be run. So I am direct running this one. So it will first start the synthesis, then we move to, then he move to implementation. So synthesis is running. So it will take little bit time, so that I am pausing this video. Okay, implementation is done. So if you want to view the report, just click on it and a report is come. So this is the report. Otherwise you have to also, here is utilization table. Here is showing this is the power. It's showing power of how much power dissipated on chip, and this is previous one. Here is showing a status. Implementation is done. Two warnings, so just ignore it. It will click on here, it will show. If you want to know message, showing message will show. This is just ignore it. This is not a very big reason to create any error. So move to clicking here. If you are clicking here, it is showing the different report, power or reports after implementation. So here is the option, you can change your supply environment. Actually this is the method to change for different grade. Actually if you are selecting working as industry level or commercial level extended, you can choose here. But by default you don't change, make it by default. So here is the power showing power dissipation. Okay, now move to generate bit stream file. Actually this bit stream file is input file of your board. So after the generating of bit stream file, we dump this bit file to your board. So firstly we generate bit stream file. Click on generate bit stream, it will start generating. So here is the running bit stream is showing. Okay, it will take time. If you want to showing the status, here is the showing. This is for more TCL console. Okay, now move to go to generate memory configure files, or go to hardware manager. If you go to here, we are showing different file. This file I will talk later about this one. First we go to open hardware manager. So when you open hardware manager, you have to click here and open target, and next, and connect your FPGA board. So presently I have no FPGA board, so I am not showing here. So it is working. So when you connect your FPGA board, here is the come program. So here is select your program and run it. So until we connect the FPGA board, it will not run. So it is showing error here, no valid target. So after the connecting board, here is the option to mount the dump your bit stream file on your board. Okay, so I move to here. I want to tell some important thing here. If you want to show in the form of change the radix, anyone hexadecimal, it show in hexadecimal. Okay, if you want to change in show in binary form, just click on the show in binary. Okay, show in binary. So move small, zoom out, zoom in, zoom out, many option. So this is the basic procedure of Vivado tools to run here. In next video I will explain VIO ILA and debugging of code. So thank you for watching my video. If any query related to this, just comment on my video and subscribe my channel.